Today we are discussing about operating system structure by Gorlin Sushma, Assistant Professor of Computer Science Department, Emmanuel Arce, JJ College of Engineering, Nattala. What is operating system structure? An operating system structure defines how its core components are organized and how they interact inside the kernel to manage computer hardware and software resources because operating systems are large and complex. That means the way an operating system internal parts are organized and arranged. We can handle many jobs such as managing memory, handling files, controlling devices, etc. Kernel means it's a central part of an operating system that directly controls the computer hardware, like the CPU. It acts as a blueprint. There are 5 types of operating system structure. They are monolithic structure, layered structure, microkernel, modular structure, hybrid, etc. Monolithic structure. Operating system with no well-defined structure, no clear separation of interfaces and functionality. All operating system services run in kernel mode. That means single address space. Example, MS-DOS original Unix. OS with no well-defined structure. That means the operating system doesn't have a clean, organized layout. Okay. Doesn't have a clean, organized layout. That means it is a irregular in structure. Then no clear separation of interfaces and functionality. The different parts aren't clearly separated, they are mixed together. The interfaces and functions are not clearly separated. All operating system services run in kernel mode. That means the sharing the same memory space. They share the same memory space. There is no walls between them. Examples: MS-DOS, the Unix, that means only the original Unix. Advantages of monolithic structure: fast extraction, fast execution, minimal overhead. That means since all parts of the operating system run together in the same space, they can talk to each other directly and instantly. This makes the system run faster. Simple design and implementation. Because everything is bundled into one program instead of being split into many separate layers. So, it's easier and quicker for developers to build in the first place. Second one is layered approach structure. Operating system broken into number of layers or levels. That means the operating system is divided into stack of layers, one on top of another, like a layer of cake. Then bottom layer, layer 0, that is the hardware. That means the actual physical parts of the computer. Only the hardware. Top layer. Layer N. That is the user interface. The part the user directly interact with. Then each layer uses functions of lower layers only. That means each layer can only use the layer directly below it. It can't skip the layers. Next one, the each layer provides services to layers above. Each layer offers its services to the layer sitting above it, like passing a job up to the chain. Advantages. Simplifies debugging. That means since each layer is separate, if something goes wrong, it's easier to figure out which layer has the problem instead of digging through one giant mess of code. Next one is clear modularity. Modularity means the system is split into clean separate pieces. Each piece has its own clear job, so the whole system is more organized. Third one is easy to test independently. We can test each layer on its own, one at a time, without needing the whole OS to be finished. This makes finding bugs much easier. Next one is better maintainability. Maintainability means how easy it is to update or fix later. Since the layer is separate, you can change or improve one layer without breaking the others. Next one is microkernel. Remove all non-essential components from kernel. That means take out anything that isn't absolutely necessary to run the system, like file system, device drivers, networking code, etc. Implement them as system and user programs. Those removed pieces doesn't disappear. They still exist, but now they run as the regular program outside the kernel. Result: small kernel with essential services only. That means because we removed so much, the kernel itself becomes tiny and lean. This is actually why the term microkernel comes from a small minimal code. Next one is kernel provides process or memory management IPC. That means the only jobs left for the kernel are managing processor, IPC, etc. That means stopping the or scheduling the programs. Managing processes means starting, stopping and scheduling programs, or managing memory. That means allocating RAM to programs. Then IPC means inter-process communication. That basically letting these separate outside programs talk to each other and to kernel. Then example of microkernel, that is Mac OS X built on Mac microkernel. In this real world proof this design works, Mac OS core is built on something called Mac, which follows this microkernel. Then advantages of microkernel. New services with a kernel modification. Since most features run as separate outside programs, you can add brand new features or services without having to touch or rewrite the kernel itself. Second one is more secure and reliable. The kernel is small and simple. There is less code that could have bugs or security holes. Third one, easier to port to new platforms. Porting means adapting the OS to run on different hardware, like moving from one type of processors to another processor. Since the kernel is tiny, there are much less code that needs to be rewritten for the new hardware. Last advantage is better fault isolation. If something crashes, it contained. Since services run as separate program outside the kernel, a bug in the one of them won't necessarily bring down the whole system. Next one is modular structure. That means design modular kernel with core components. We can build the kernel with just the essential core parts. Okay. Other services added as dynamically loadable modules. Essentially, it isn't permanently built into the kernel. That is, it is permanently built into the kernel. Instead of separate the modules like plugins. Modules loaded during the runtime or booting time. That means these plugin modules can be added either boot time or runtime. Boot time or runtime. Boot time means when the computer first starts up. Runtime means why this system is already running. Example, when we plug in a new USB device and its driver loads automatically without restarting your computer. Next one is combines benefits of layered and microkernel. This design cherry picks the good parts of the two earlier approaches. From layered architecture and from microkernel. Example, Solaris OS. It is an operating system by Sun Microsystems. Resembles layered structure. defined protected interfaces. That means, like the layered design, modular kernels have clear, well-defined doors between different pods. Each module knows exactly how to talk to others through these set of rules, which keeps things organized and safe. More flexible than layered modules can call only other modules. In this layered system, layer 3 can only talk to layer 2, layer 2 can only talk to layer 1, and so on. In this layer 3 can only talk to layer 2, layer 2 can talk to only layer 1. That's it. Then, flexibility of microkernel with the efficiency of monolithic. That means, this is the real selling point. Microkernel flexibility means easy to add or remove pieces since they separate. Monolithic efficiency means fast performance because in monolithic system everything runs together directly. Then easy to add or remove modules without recompiling kernel. Recompiling means rebuilding the entire kernel's code from scratch. It is a slow technical process. Next one is good balance between security, modularity and performance. This design doesn't max out any single one of these three things, but it gives you a solid, well-rounded mix of all three. Hybrid systems. In this, modern OS combine multiple structure approaches. That means, nowadays we are using the latest version of model operating system. Instead, they mix and match different architecture dependently on what works best for each part of the system. Mac OS and iOS. Apple operating system are the real world examples of this mixing. Then Android or Google. Android is the built on top of the Linux kernel. These systems layer different architecture styles for optimal design. Instead of picking just one architecture and being stuck with its limitation, real system combine the strengths of multiple approaches.